All right, today what we're going to talk about is sine and cosine, and we're going to find ratios, side lengths, and angles similarly to how we did in tangent. So just as a reminder, sine is going to be the opposite side of the angle divided by the hypotenuse of the triangle. Cosine would be adjacent divided by hypotenuse, and tangent is going to be opposite divided by adjacent. Commonly asked question is, how do you know which one of these three to use? And the solution to that is you have to know what the side is given that angle. Is it an opposite side or an adjacent side, or is it the hypotenuse of the triangle? And then based on what you're given is going to allow you to use the specific trig function. So if we look at example 1 here, we're going to do sine and cosine of angle x and angle y. And all we want is a ratio. And again, keep in mind with ratios, what do we want is an answer written as a fraction. That's it. There's no calculations to be done. So if we look at angle x here, right? If we look at angle x, visually what I like to do is make one of those angle markers that we sometimes see in geometric shapes. And from that angle, draw a line all the way across the triangle. And what that does for me is a visual reminder that this side that is drawn to is opposite the angle that it came from. So in this case, because we want sine, we want opposite and hypotenuse. So the sine of x would be 64, which is the opposite side, divided by 80, which is the hypotenuse of the triangle. So sine of x would be 64 over 80. And for right now, we can keep the fraction written like this, just so I can help you identify the different parts of the triangle. All right. Next, what we're going to do is find sine of y. So based on angle y, sine is going to be opposite. So like we did for angle x, we can draw a line across the triangle and identify this being the opposite side. So this would end up becoming opposite. So our ratio for sine would be 48 divided by 80. When we go to cosine, we're going to do cosine of x first. And so for cosine, we need adjacent and we need hypotenuse. So the hypotenuse of the triangle is going to be across from the 90-degree angle. And then we know that if we draw a line across from the angle, this is going to tell us the opposite. So for me, that leaves this line here, 48, to be the adjacent side. And so out of these three, I'm going to need these two here, the 48 and the 80. So the cosine of x would be 48 over 80. When we go to solve for the cosine of y, okay, again, I identify this being the hypotenuse because it's across from the 90-degree angle, and I identify 48 to be opposite, which I don't need in this example, so I don't need 48. So what I need is 64 and I need 80, and that's going to form my ratio for the cosine of angle y. All right, for missing side lengths, again, I want to refer you to that there's two ways to find side lengths. We're going to have a variable on top, or we're going to have a variable on the bottom. And that's pretty much going to be the theme throughout the trigonometry unit. So if we look here at this problem here, all I want you to do in this example is to find side df, which we can call it x, for example, or whatever letter variable you want. So our angle here is 20. So if we were to draw a line across, that identifies our missing side to be the opposite side. And if we look here at 8, 8 is across from the 90-degree angle. This is going to be our hypotenuse. So in this example, it does not tell us which trig function to use, but because we are trying to find the opposite side and we're given the hypotenuse, we're going to end up using sine. So our equation would be sine of 20, sine of the angle, is equal to the length we want divided by the hypotenuse. So because the variable is on top, we're going to cross multiply. So for most calculators, when you type in sine of 20, you're going to have only one parenthesis. And we want to make sure that we close that parenthesis off. So we hit sine of 20, multiply by 8, so hit times 8, and you're going to get the answer to be 2.736, which we can just call 2.7, and that would be the missing length for that side. Over on example B, I specified to find ST. So based on this angle, ST is going to be the hypotenuse. So 10 in this case is going to be the opposite side because we can draw a line across from the angle that we're given. So because we have opposite and we have hypotenuse, we're going to use the sine function. So in this case, we're going to take sine of the angle, and that's going to equal to opposite divided by the hypotenuse. In this case, we do not know what the hypotenuse is. In this example, the variable term, the unknown, is in the bottom, the denominator. So what we do, the shortcut, is to change what's on the left by itself with the denominator. So these two things, the entire term here and this term here, are going to change places. And so we're going to end up with this. The variable is equal to 10 divided by the sine of 50. Now, for most calculators, all you do is type in 10 divided by sine of 50 and equals or enter, and you should get approximately 13.1. So it becomes quite easy. So I like the switch method because that is exactly what you would type into the calculator. And by doing this, we're eliminating one algebra step, which I'm okay with you guys doing. All right, here's another example here where we're going to try this. In this example, I'm only going to solve for the side x. So based on the angle given here, we know that x has to be the opposite because from the angle we can draw the side across. And we know that this side is across from the 90-degree angle, which is going to be the hypotenuse. So because we want to find the opposite and we're given the hypotenuse, we're going to use sine. Okay? So our equation will look something like this. Sine of 57 is equal to x over 25. The variable's on the top, so we're going to cross multiply. And again, I encourage you and remind you to close the parenthesis on the angle. So sine of 57, close the parenthesis, and then times 25, and you should get 20.975, which is approximately 21. For the next example here, we have the angle given here, and if we draw our line across, this is opposite, which we don't need in this problem. We don't have it, we don't need it. And we know that 20 is going to be the hypotenuse, which leaves x, the variable in this case, to be the adjacent side. So in this case, we need adjacent and we need hypotenuse, which is going to be cosine. So we set it up as the cosine of 35 is equal to x over 20. The variable's on the top in this case, so just like the previous examples, make sure we close the parenthesis with 35. So cosine 35, close the parenthesis, times 20, and that's going to give you an answer of approximately 16.38, which is, we can round to 16.4. In this example here, this is in fact the same exact problem, except instead of just a triangle, we have a flagpole. And so we want to find the height of the flagpole. So the work is exactly the same as the problem above. All right, now we're going to do a couple examples where we find angle measures, missing angle measures. So in this case here, we're going to look at the angle and find that this is going to be opposite, and this is going to be the hypotenuse. So opposite and hypotenuse is going to lead us to use the sine function. So our equation will look something like this. All right, because we're trying to find an angle, we need to use the inverse function, in this case the inverse sine function. So what we're going to do is, in the calculator, typically you would hit the second button and then whatever function you want, in this case sine. So if you hit second sine, you're going to get this -1. And the shortcut I want you to do, or prefer you to use, is to put this fraction in that parenthesis. So it would be second sine, and then 6.5 divided by 10, and then you can close the parenthesis, and you're going to end up getting approximately 41 as your answer. And this is a rounded answer to the nearest degree. When we come over to example B, we look at our angle we have, and we know that the missing side is the opposite side. So because we do not have the opposite side, we're going to have adjacent and we're going to have the hypotenuse, which is going to be the cosine function. So in this case, 27 is going to be the adjacent side. So when we set up our expression, cosine x is equal to 10 divided by 27. Because the angle is missing, we're going to use the inverse, the -1 cosine button, to figure out the angle. So if you hit second cosine, 10 divided by 27, that's going to give us our angle for this particular problem. And you should get approximately 68 degrees for your answer. This last example here, it asks you to find angle Q. So from angle Q, we draw our line across and identify this as being the opposite side. right? Angle R, the opposite of that, is going to be the hypotenuse. So in this case, we're going to use sine because we have opposite and hypotenuse. And so this is going to be our equation. Sine of angle Q is equal to 15 divided by 28. Because we're trying to find angle Q, we want to use the inverse sine function, the sine -1 button. So on most calculators, you'll hit second sine 15 divided by 28. And then when you enter that, you're going to get approximately 32 degrees for your angle. So far in this lesson for sine and cosine, we've reviewed ratios, which the answer will be written as a fraction. We went over side lengths, talking about variables on top, variables on bottom, and we solved for missing angles by using the inverse sine and cosine button.